Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is Search in Rotated Sorted Array Part 2. So this is a follow-up problem for this problem, Search in Rotated Sorted Array. Let's quickly read the problem statement out and then see what we have to do. There is an integer array, nums, sorted in non-decreasing order. So it's in ascending order, not necessarily with distinct values. Before being passed to your function, nums is rotated at an unknown pivot k. So k lies between 0 to nums dot length, such that resulting array looks like this. So what the problem statement is saying is, let us take the example which is being provided. Or anyhow, let's take our own example. In this example, we are not considering the duplicates. Not considering duplicates. This part we will deal separately. As of now, we are not considering duplicates in the array. Let's say all the values in array are unique. So if array is something like this, now it may have been rotated at a unknown pivot. Let's say I decide it should be rotated at this pivot. Then what will the resulting array will be? This part from right hand side of the pivot will be shifted to the front of the array, and the resulting array will be 4, 5, 1, 2, 3. So I hope you are able to understand it. What by rotation is this is meant here. So yeah, given array nums, after the rotation and an integer target, you have to return whether that target is present in that rotated array or not. For example, along with this array, you will be given a target. Let's say target is 5. Now you have to tell when this rotated array will be passed to your function. This array will be passed. Whether this target is present in your array or not. Target present or not. Also, you have to make a note that the array might be rotated. It's not necessarily uh, true that the array will always be rotated. For example, an array like this can also be passed to your function without rotation. The problem statement is saying that it might have been rotated. So we will uh, check for the case in which the array is rotated, and the case in which the array is not rotated will be covered in that case itself. So yeah, that's the problem statement, and you must decrease the overall operation steps as much as possible. So we have to write a solution which is the most optimal solution possible. In that solution, the number of operations will be as much as low as possible. Most optimal solution. So before approaching the solution of this problem, I would highly recommend you to check the solution of this particular problem. This is a problem that was this problem sorted search in rotated sorted array part 2 is just a follow of this problem. So the only difference is the values here are not unique, and in this one the values were unique. So I will be providing a link for the video explaining the solution of the previous part in which the values were distinct. So before proceeding to the solution, it is recommended that you should check that part out, and the link will be provided you to in the I button on the top right of the screen. So now I hope you have gone through that solution video. Now there is a just a little tweak that we have to made in that solution so that we will be able to form an answer of this particular solution. And we are asked follow up that will be asked from us is, if does duplicates affect any affects the runtime complexity of your program? If yes, then how? And if no, then why? And so what we have done is, the only thing that we have changed in that program is, so instead of asking for the index at which the target will be present, it is asking just for a true false value whether the target is present or not. So there will be two changes in the code. First change will be, now consider this scenario. Let me quickly erase the board. Now consider this scenario. 1 2 3 3 3 3 4 5. Now let's say this is the given input array. Before rotating it, now you will be passed the array after rotating it. So let's say I decide to rotate this at this pivot. Okay. And the rotated part will be, this will be the rotated part. And what was the original part? Yeah, it's the original one. And this will be the rotated array. So what will happen is this part from the right hand side will just come in the front here. So if let's say you are currently, your mid position is currently at this index, now you will not be able to decide whether you are in rotated part or non-rotated part. This is the rotated part. This is the non-rotated part. Decide by looking at the last index and your mid position, whether you are in rotated part or non-rotated part. Because if let's say this value have been 5 and this value have been 6, 7, 8, 9. Then you could have easily checked that the value at the middle position is 7 and which is lesser than the which is greater than the right of the current search space, right? This will be the right pointer and this will be the left pointer pointing to the start of the search space. So the last element of the array is smaller than the middle position element of the array. So we are in the rotated part. Then you would have easily guessed that in which part we are in. But here that's not the case. You cannot check whether you are in the rotated part or not. So how you will be doing the checking part? The only thing that you can do here is here two conditions are being satisfied. First is your nums of left. This is the left. This is the right. It is equal to your middle position element. And your nums of the element at the right index is also equal to your middle position element. So in this case, the only thing that you can do is you should move your left and right pointers towards the center of the array. What you will do is you will shift this left and right pointers. You will shift them to one position ahead. You will move left to here and right to here. You will keep doing so till this condition satisfies whenever you generate a new middle position in your search space. So essentially what will happen is there will be a point when your left and right will reach here. Your left will be pointing to here and your right will be pointing to. So here you can check that your 4 is greater than 2. So your middle position, it will be, let's say this is the middle position. Now the middle position element is greater than the last element of the range. So you can easily tell that in which part you are in. So it will be the same logic for the problem that I have provided a link for. And we have to just add this condition. In this condition, what we will do is we will increment the left pointer, move the left pointer towards the center, and also we will move the right pointer towards the center. And what we will do is we will move right pointer towards the center by decrementing it. I hope you are able to understand. It will be left plus plus. So yeah, and what we will what factors in this uh, particular case will have, what effect does this particular case will have on time complexity of solution. or you can say that what effect duplicates will have. Any duplicates, then what in each operation you are let me quickly take another slide. If there are no duplicates, then in each operation you are dividing your search space. What is the search space here? Search space here is nothing but the indices of the array, which are from 0 to n minus 1. Let's call the length of the nums array as n. So these are the indices. This is the search space that I am talking about. So your search space by 2. So the overall time complexity should have been, if there were no duplicates, O of log of n. Since we are at each operation we are dividing our search space by 2, so these number of operations will be required, log of n operations. But here what is happening is, to handle the duplicates case, to handle case, we have to just decrease our search space in a linear way. We are just able to linearly decrease the search space. What I mean by linear decreasing is, we are just decreasing the search space by 2. We are just, in case of duplicates, let me quickly change the color. This is in case of duplicates. At worst case scenario, pardon me if some spelling is incorrect. I hope this is not affecting your learning. We are just decreasing search space by 2 by moving left and right pointers center of array. So in that case, the overall time complexity will be, in the worst case, the overall time complexity will be O of n. N is the length of the nums array. So these number of operations will be required in worst case. And what will the worst case? All the values in array are same. And let's say you have been asked for value to find target. Let's say 2. Then in each operation, what you will do is, say initially your left was pointing here, this was left and this was right. In each operation, you cannot do anything like that, dividing the search space by half. Only thing you can do here is, you can move your left and right position, left and right pointers towards the middle of the array. We will keep moving them, and this will take you O of n time complexity and n number of operations. So this will be the effect that the problem statement is asking in a follow-up question. This follow-up question. So how would this affect the runtime complexity? How and why? So I hope you are able to understand it. So in the solution of this previous part problem, which I have provided you in the I button. It will again be showing you in the I button here at this point of the solution on the top right of the video. So please check that out if you haven't till now. It is necessary to understand this problem. So what we have just studied is, if this is for the handling the duplicates case, this, or let me quickly use on stars so that you will be able to differentiate what is being changed. This is different. So what is different is condition is to handle duplicates present in the nums array. What you will do is you will move your left and right pointers to the center of the array, because you will not be able to determine whether you are in rotated part or the non-rotated part of the input array. So what the rotated and non-rotated part is I am talking about? This is the rotated part. The part that have been shifted to front of the array from the back of the array. And this is the non-rotated part, the part which was previously at the front of the array before the rotation was made. So I hope you are able to understand what a non-rotated part and rotated part is. So this is to check that case. And in this particular problem, we are not asked to return the index at which the target is present. We are just simply asked whether it is present or not. So if it is present, then this thing is also different. Instead of returning the index of the target element in the array, we are just returning whether it is present in the array or not. So if the middle position happens to be equal to the target, then we will return true. And if after completing all of this binary search, we are not able to find the element, if we are not able to find the target element, then we will return false. I hope you are able to understand the solution of the problem. And if you still have any doubts, please feel free to ask them in the comment section. Thank you for watching. Thanks.